Hey, welcome to another lesson in Algebra 2. This is Lesson 3, Square Root and Cube Root Equations. In this lesson, we're going to solve equations using square roots and cube roots by squaring or cubing both sides of an equation. So that shouldn't surprise you too much. When we had x squareds, we saw that we can sometimes use square roots to solve. Now we're going to have square roots, and we see we can use squaring to solve. But there's an important thing about this, and we looked at this kind of when we talked about inverses in lesson 1. Squares and square roots are not perfect inverses. Cubes are, but not squares and square roots. So the issue here is that if we say a squared equals b squared, that doesn't imply a equals b. I mean, it does, I guess, about 50% of the time, but not always. And we're going to be acting like it does. So we really need to check our answers because sometimes we'll get things that aren't true. Let me give you an example of what I mean. For example, let's say that I had, I tell you that a squared is equal to b squared. Can we then, I'm saying you can't automatically conclude that a equals b. Well, can you think of two values that a and b could be so that this statement's true, but this one down here is false? Well, what if a equals 4 and b equaled -4? Is it true then that 4 squared equals -4 squared? Well, yeah, it is. But 4 does not equal -4. So because of that, we need to be really careful. All right, let's take a look at what we have here. On the first equation, I've got the square root of x minus 3 plus 2 equals 4. What we want to do is isolate this square root function. So get it alone, and I'll subtract 2 from both sides. Now, once you've got the square root alone, and that's usually what we'll want to do, you'll see a couple cases where we don't quite do that. You square both sides, which gives you x minus 3 equals 4. Which tells me that x equals 7. But I'm not 100% sure that's right because I need to check for an extraneous solution. An extraneous solution is a wrong answer when you didn't do anything wrong. So we need to make sure that even though we did the problem right, that this is still a right answer. Plus 2 equals 4. We want to go back to the original. I didn't write down the original. There we go. Square root of 7 minus 3 is the square root of 4. The square root of 4 is 2, and 2 plus 2 equals 4, so it works. So I'll put it in solution set. All right, let's try the next one. Square root of 4x minus 1 equals x. So I'm going to add 1 to both sides so that I can isolate the square root of 4x. Then what I want to do is square both sides. The square root of 4x squared becomes just 4x. And then over here on the right, I'm going to be squaring a binomial. So I square the x, then I multiply x plus 1 together and double it for the 2ab. And then square the 1. If you're not sure how that works, be sure to just multiply it out like this and FOIL it. All right, now if I set this equal to 0, I get x squared minus 2x plus 1 equals 0. And this can be factored as x minus 1 squared. It's x minus 1 times x minus 1, which tells me x equals 1 is my only candidate. But let's make sure it's right. The square root of 4 times 1 minus 1, does that equal 1? Well, the square root of 4 is 2, and 2 minus 1 does indeed equal 1, so it works. All right, let's take a look at our next one. All right, on this one here, again, I'm going to work to isolate the radical, giving me x minus 4 is equal to the square root of 3x plus 6. I will then square both sides, giving me x squared minus 8x plus 16 is equal to 3x plus 6. Setting this equal to 0 gives me x squared minus 11x plus 10 equals 0. So I get x minus 10 and x minus 1 as my factors. X equals 10 and x equals 1. And if you plug them in, you'll see that the x equals 10 definitely works, but the x equals 1 does not. Let's see what happens when we plug in the 1. you get 0 equals 6, which is a false statement. So that's not the right answer. Just the number 10 is the right answer. Okay, I have a few practice problems for you. A little bit of a warning on B and C. You're going to have a number in front of the radical. And if you can divide by it without getting fraction, do so. But otherwise, don't. Don't divide by it. Just square both sides with that number there. All right, pause the video and give it a try. All right, let's see how we did. I moved the 3 over. And I square both sides. So I get x equals 50. And if you plug that in, you should see that that works. All right, let's try this next one. All right, so on this one here, I'm going to isolate just the 2 root x. And then I will square both sides now, which will give me 4x equals 9x squared. Multiply these two together and double them, so it's minus 30x, and then plus 25. Set this equal to 0. 9x squared minus 30, 4x plus 25. Okay, and this does factor. And it factors as 9x minus 25 and x minus 1. So, bit of some yucky answers. 25 over 9 and x equals 1. Now, the x equals 1, if you plug it in, you get 2 times 1 plus 1 is 3, and then 3 minus 1 is negative 1. So that doesn't work. The 25 over 9 does work. It really does. You just got to be careful with your fractions. 2 times the square root of 25 over 9 is 5/3. You square it at the top, you square it at the bottom, plus 1. And then you have 3 times 25 over 9 minus 4. Well, the 3 and the 9 reduce. So this becomes 10/3 plus 3/3 equals 25/3 minus 12/3. Each one is 13/3. All right, let's take a look at this last one here. Okay, again, I'll move the 5 over. And I'll square both sides, giving me 16x equals x squared plus 8x plus 16. So 0 equals x squared minus 8x plus 16 when I set it equal to 0, and I get x minus 4 squared. So x equals 4. And when you plug it in, you'll get 4 times 2 is 8, minus 5 is 3, and 4 minus 1 is 3, so it works. So that one wasn't too bad, as long as you remember that it's easier to keep the 4 times it. And I just want to talk a little bit about why that's okay. So if I have 4 times the square root of x and I square it, when you have a product that is squared, you apply the exponent to each factor. But if this was 4 plus root x, that'd be very different. I would have to square it like this. I'd have to FOIL that out, and you see it ends up becoming 3 terms. So be aware of that it's okay to distribute an exponent over multiplication, not addition, which is why we typically try and, get it down to at least this before going forward. All right, if you have more than one radical, you may, not always, but you may need to square multiple times. Let's take a look and see what happens. So on this one here, I can actually square both sides right now, or I can move this over to the other side. And this is just what I typically like to do, but it actually works both ways. There's no way to completely isolate a radical, though, because there's 2 of them. So we just, that kind of idea doesn't work here. But I can still square both sides. And the squared cancels the square root here. And then on this side, I have to FOIL this. And again, it follows this a plus b squared pattern. You square the first term. Multiply the 2 together and double it. So 3 times root x is just 3 root x. And double it, you get 6 root x. And then I square the last term, making it a positive, just a single x. All right, and then I'll move the x over, and I get a negative 3 equals 9 minus 6 root x. I'll move the 9 over, so a negative 12 equals negative 6 root x. Now, at this moment, I'm not just going to square both sides. I'll go ahead and divide both sides by the negative 6, so I get 2 equals root x, which gives me x equals 4. And let's see here. Let's check that. 4 minus 3 is 1, plus 2 is 3, so it works. All right, let's try the next one. All right, this time I'm just going to go straight to squaring both sides. When I square this side, it cancels the radical, giving me 3x plus 2. But on this side, you can't just call this 4 plus x. You can't do that because there's a plus sign, as we just talked about. You got to FOIL this out. And when you do, you'll end up squaring the 2, then multiplying these two together and doubling it, so it'll plus 4 root x, and then plus x. If you're not sure, put it out here. Do this, and then just do FOIL. All right, I'm going to kind of isolate this radical as best I can. So it becomes 2x minus 2 equals 4 root x. And I can't divide by 4 without getting some nasty fractions, but I can divide every term by 2. So I will. And that'll make my numbers a little bit smaller. Now I'll square both sides. And that gives me x squared minus 2x plus 1 on the left, and just simply 4x on the right. And then setting this equal to 0, I get that. This doesn't factor, though, so I need to use the quadratic formula. So it'll be x equals opposite b plus or minus the square root of b squared minus 4ac all over 2a. So you end up with 4 plus or minus the square root of 12 over 2. And the square root of 12 is 4 times 3 it's 2 root 3. So I have 2 plus or minus the square root of 3. All right, now this would be really difficult for us to just do this by hand. We're not going to be able to just confirm very easily which one of these is correct. So we would want to use a calculator to confirm that, and you're going to end up with just 2 plus the square root of 3 being the answer. And you just want to plug those into a calculator and see if they equal the same thing. All right, let's take a look at our practice problems. The first one's not too bad. The second one looks ugly, but I promise you it works out to be not too bad if you just square both sides right at the beginning. All right, give it a try. Okay, hopefully you gave that your best effort. And if I move this 2 root x over like that, I can then square both sides. And this one actually works out real quick. Didn't even give me a quadratic. So I just get 2 is equal to 3x. So 2/3 is equal to x. And if you plug that in, you get something that might not be the most obvious of correct answers. Let's take a look. When you plug in the 2/3, you get 2/3 plus 2 minus 2 times the square root of 2/3. And we got to make sure these two numbers are equal so that it equals 0. Getting a common denominator makes this a 6/3. So this becomes the square root of 8 over 3 minus 2 times the square root of 2 over 3. Well, 8 is 4 times 2, which is 2 times 2. So I can pull a 2 out of the top and make this 2 root 2 over the square root of 3. Remember when we square root a fraction, square root the top, square root the bottom. Likewise, over here, I've got minus 2 times, we'll split this one up as well, square root the top, square root the bottom. And you can see that this is 2 over 1, so these definitely do equal 0. Now, you may be thinking, wait a minute, we're not supposed to have radicals in the denominator, but that's fine for right now. We're just checking if we're just checking to see if the solution is good. It's totally okay that, we left a radical in the denominator. We just want to make sure that it did indeed equal 0, which it does. All right, let's take a look at the next one. Right off the bat, like I said, just square both sides, and 2 squared is 4, and then this radical goes away. I hope you realize, though, that the radical is a grouping symbol. We need to keep these grouped because this whole thing was times 2. On the right-hand side, when I square the square root of 2x, I get just 2x. Then I multiply the 2 together and double it, so it becomes 4 root 2x, and then plus 4. Distributing gives me a negative x plus 12. And I'll just put everything together on one side. I get 3x plus 9 equals 4 root 2x. And I'll square both sides again. And I think that's correct. It did give me a 9, I believe, right? Oh, it's not. It's not a 9 at all, is it? Felt weird. Okay, 12 minus 4 is 8. Okay, now we're going to square both sides. I'll get 9x squared. 3 times 8 is 24, so double is 48. Then plus 64 equals, I'm squaring this. Square the 4, you get 16. Then the root goes away. Root 2x times, so 2x times 16 is 32x. It's a quadratic, so I set it equal to 0. And trust me, I would not give you something this big to use a quadratic formula on, so it must be factorable. And it's going to factor, I believe, as 9x minus 8 and x minus 8. So you get x equals 8/9 and x equals 8. And this 8 does not work. If you plug it in here, you'll see that it's a negative 2 plus 3. Square root of 1 is 1 times 2 is 2. That's not what you get over here because you get 6. So the 8 doesn't work, but I'll leave you to confirm that the 8/9 does. A little bit tricky fraction stuff, but we went over that earlier. All right, last, I want to just look at some cube root functions. These are much easier because there are no extraneous solutions. If you have a cube root, all you have to do is cube both sides. So that gives you x minus 8 equals 8. And then you get x equals 9. This next one here, you can pause the video right quick and practice it if you like. Otherwise, I'm just going to go ahead and go through it. We cube both sides here. You get x squared minus 6x. 3 cubed is a 27. So I end up having to solve this quadratic. And you get x equals 9 and 3. And they're both going to work. 9 and negative 3, excuse me. Because the cube and cube root are perfect inverses. And that's it for this lesson.